We're going to actually call this lesson 5.5 part 1 because I'm splitting it in half, right? So we're just going to do the story problems today and save the rest for another day. Two more story problems, coin story problems. So Yolanda's collecting dimes and nickels. She has a total of 195 coins in the bag, and the total value of the coins is $12.40. Here we go. How many of each coin does she have in the bag? What would you like to define for our variables? What are they asking us? How many coins, right? What kind of coins does she only have? Dimes and nickel. Is it the number of them or the value of them? What are we looking for? Number of them. So, cool. We'll let X be like the number of dimes and Y be the number of nickels. A lot of people might use D's and N's. It's totally fine if you wanted to do that, you know. Again, if you switched them around, like nothing new today, just a different style of story problem, right? So it's also, can you kind of smell, it's in the total category, right? You know, it's like she has a total of 195 coins in the bag. So all the dimes she's got, or in other words, the number of dimes she has, and all the number of nickels she has, isn't that a total of 195 nickels, right? Or excuse me, coins, I should say. What do you want to write for that equation? X plus Y equals 195. That equation is usually not bad at all. But we kind of notice the other ones that we've had like this that had like 3 different monies involved. It's like, bro, we only were given one value of money in English. We have to know the value of a nickel, and we have to know the value of a dime. And a lot of people in today's world might not know that because we don't deal a lot with change, you know. So do you know how much of a dollar a nickel is worth? 5 cents. How would you write that as a decimal? Is it 0.5 or 0.05? 0.05 for a nickel. Oh, my bad. X is dimes, so I just messed that up. How much is a dime worth? 0.10. So that's something that you might want to watch out. So 10 cents for every dime plus 5 cents for every nickel, and shouldn't that add up to $12.40? How do you feel about that bad boy? How would you solve it? Substitution or elimination? Elimination. You please pause the video and get that done. So I took the top equation times negative 0.10 and multiplied down here. Now all I got to do is add those together. X's cancel. This would be negative 0.05y equaling 1240 take away 1950. I got negative 7.10. And if I divide that by a negative 0.05, I should get a normal number, like an integer, because it's like nickels and dimes and stuff like that. You shouldn't get a decimal. I got 142. Did you get 142 of those? Or did I make a mistake, which is very likely sometimes? 142. I solved for y, by the way. Maybe you canceled your y's. So. Then I know that there's supposed to be 195 total coins in there. So if I do 195, take away 142, there's got to be 53 left for the other bad boy. So we'll answer the question. 53 dimes and 142 nickels. And honestly, I'll bet we could have handled that question without me, but we are advanced. Normal student might struggle bus knowing that you had to put the 0.10 and the 0.05 in front of it. They're like, well, what do you put for the value of these? It's like, it's what a nickel's worth and it's what a dime is worth. If they said quarter, what would you do instead of, what would you do? 0.25. Are we cool with that? So you got to assign the money value. Those, no big deal. Problem. Mixture problems are kind of weird. Rita needs 120 milliliters of 22% acid solution for a chemistry experiment. But she's got to mix 2 acid solutions together. They're called solution A and solution B. That can be mixed in that. Solution A is 10% acid. Solution B is 40% acid. How much of each solution should she create to create the mixture? Once you get used to these, you will definitely recognize by reading, this is a mixture problem. Are you with me on that? It is a mixture. And we are smart. Are you cool with the fact that 3 of these numbers have percents with them and 1 of them does not, right? So all the percents will go in one equation. And here's why I did my little example that didn't get recorded for this video, but it was in person. 10%, 40%, 22%. You should know which one is the final mixture. Is it the high, is it the low, or is it the middle? The middle. Like there's no way when you mix them together it can be stronger than 40%, and it has to be, or excuse me, it can't be stronger than 40%, it can't be like less than 10%. Doesn't the mixture have to be somewhere in the middle? So they mix together the 10 and the 40. Are you with me on that? That's who they mix together. So when we define our variables, since they named these solutions, we'll just kind of call it this. How did they measure it, though? Like in this one, do you see how they measured it in like milliliters, right? Because that's what Rita's doing. So we'll say, like, I'm going to actually let A and B be the variables this time instead of X and Y, because I think that makes a lot more sense. It's just going to be helpful. So I'm going to let big A be the milliliters of solution A. And then in parentheses, it kind of helps to like know that was the 10% value. And like, I'm going to let capital B be the milliliters of solution B, and it helps to like totally have 40% in there. Sometimes they don't even call them like solution A and solution B. They just call it a 10% solution and a 40% solution. So you would say like X is the milliliters of the 10% solution and Y is the milliliters of the 40% solution. But are we cool that those two got mixed together because they are the high and the low? Are we all right with that? So writing the equations is kind of weird. Guess what this guy is? The 120. The dude that doesn't have a percent by it, he is a total. Could you tell me how many milliliters of solution A they poured into the cup? How many? A, right? Sometimes we call it X, you know, like we don't know it, so they totally made up a letter for it and we're calling it A. How many milliliters of the 40% did they pour into the cup? B. Isn't that the only two things that they poured in? How many milliliters should it all add up to be? 120. So all the milliliters of solution A, which we called A, plus all the milliliters of solution B, which we called B, shouldn't that add up to be 120? And it follows the same suit as before. That's milliliters plus milliliters equals milliliters. Are we okay with that? The next one is where all the percents go in. So isn't solution A 10% of that guy, right? So I'm going to change it to a decimal. Are you guys kind of cool that when you change a percent to a decimal, oh, we're changing this percent to a decimal. Are you guys cool that you move the decimal 2 places to the left, right? So how about 0.10A? How about what we would do for B? What percent of that is like this solution? What would we do 40%? How would we change that? What would that be as a decimal? 0.40B. And then here's the hardest part. They want it to mix together to be 22%. Are we cool with that? So that's definitely 0.22. But here's the weird part. 22% of what? Right? Would you believe when I filled this cup, it has 4 ounces of fluid in it now, right? 2 ounces and 2 ounces. Like, isn't 5% of these 4 ounces coffee in this case, right? So I need 22% of the entire cup to be this acid solution. How many milliliters is in the cup? Say 120. There's 120 milliliters in the cup. So what you got to do on every mixture problem is this second equation. You got to take your mixture percent times the total amount in the cup. Right? There's 120 milliliters, and that's weird. We would have never thought about that. So let's figure that out ahead of time real quick. What's 0.22 times 120? Yeah, it's going to be a decimal. That's okay. So I'd like you to have it written there and then just lightly strike him out and put 26.4. That's what makes mixture problems so weird for students, is they forget that not only is it just 0.22, it's 22% of what was in the cup, right? Only 26.4 of those ounces will turn out to be this weird acid mixture, if I could get my words out. So let's solve this system. How would you solve it? Substitution or elimination? Elimination. Let's cancel the A's. Let's cancel the A's. Let's take this bad boy times negative 0.10. And then 120 times negative 0.1 and negative 12. Lightly strike that guy out. And then add those puppies up. And A's cancel. And then 26.4, that's the weird part, 26.4 minus 12. 14.4, what I got over there. And of course, how do we get rid of this times 0.30? What should we do for that? Divide. Just divide. 14.4 divided by 0.3. There you go. 48. 48 what? Like, what's that all about? 48 milliliters for solution B. So, like, they realized, okay, I got to take 48 milliliters of this solution B and put it into the cup. So then we got to figure out how much solution A. We just sub that back in. If I draw my arrow in the right spot, isn't there supposed to be 120 total milliliters in the first place? So 120 take away 48. They needed 72 milliliters of the other guy. So A was 72. So 72 milliliters of solution A and 48 milliliters of solution B. Weird. But those should add up to be 120 milliliters, and they definitely weren't even. And yes, if you're thinking, well, there's another way I could figure that out, you're right. There are definitely other ways to figure out how these should mix together. This is the way that we like to do it in the algebra class, to set up a system for it. Cool. Questions about that guy? One last one, man. Another mixture, but no percents this time. They're mixing candy together for some candy salad. So Lily's mixing candy for the baseball coaches. She can buy mini Starburst for 75 cents per ounce and sour Skittles for 50 cents per ounce. How many ounces of both of those candies must be used to create a 40-ounce mixture that will cost her 60 cents per ounce? First, let's define our variables. What are the candies she's mixing together? Mini Starburst and sour Skittles. What about them, though? Are we doing pounds of it, ounces of it, cost of it? What are we doing? So let's do ounces. And that is abbreviated OZ, by the way. I'm going back to X's and Y's. You could have done X's and Y's on the last one. I just wanted to mix it up and throw some A's and B's in there, because one of them's called solution A, the other one's called solution B. Let's look at the four numbers provided and find our oddball. How come the 40 is the oddball? What doesn't the 40 have that everybody else does have? The money, right? So the 40's got to go in his own equation. Isn't the 40 the total number of ounces that they want, right? And aren't these in ounces? So all the ounces of mini Starburst plus all the ounces of sour Skittles should add up to be 40 ounces. Please write that equation. Check it with a neighbor. Check it with mine. How do you feel about X plus Y equals 40, right? And then they are mixing stuff together. It just doesn't have percents. It's the money, right? You know, could you tell me out of these three bad boys, which two of them get mixed together? The high and the low will always get mixed together, because don't they form something in between, right? So mini Starbursts, what do they cost? I lost it. Where are we at here? 75 cents? Yeah, so 0.75x. And then 50 cents for the Skittles. And that should add up to 60 cents, right? That's all we need? Isn't it like per ounce? Right? That's what she wants it to cost, 60 cents per ounce. So what do you have to do with that 60 cents? Take it times how many ounces we have. How many ounces of candy do we have? 40. Every time. Anytime they're mixing stuff together, that second equation, you got to take your mixture number. Sometimes it's a percent, sometimes it's a price, right? Whatever it is, times the total, right? Because it's 60 cents per ounce is what it's going, right? So, cool. Let's calculate that guy ahead of time. That 0.60 times 40. I got 24. Nice. Nice little round number there. So just lightly strike him out and put a 24. Mixture problems are our weirdest ones of all the story problems we've done so far. So let's cancel. I'm going to cancel the y's. I think it's times negative 0.5 is a lot easier for me. And then lightly strike that homeboy out and add those puppies together. So that is 0.25x. Those cancel. And then adding those together to get 44. All right. So 44 divided by 0.25. Hit the right button. Did I do something wrong? Are we good? Yeah. Okay. Just checking. Sometimes I make mistakes. I got 176. Is that right? That can't be right. What did I do wrong? Thank you. I did make a mistake, sorry about that, because I struck out my negative sign right there and didn't see it. I multiplied by negative 0.5 and I couldn't see it. So that should be a negative 20 right there. That would make a whole lot of difference. How did I know it was wrong for sure? Because it's more than 176 is more than 40 ounces, right? Shouldn't it only add up to 40 ounces? So made a mistake, my bad, owned up to it. How about 4 right there? And did you get 16 when you get this bad boy instead? Does 16 sound better? Makes a lot more sense because there's no way she's getting 176 ounces of Starburst when you only need 40 ounces total, right? So, oopsie poopsie. So 16 ounces of this, and what does that mean for the Y's? How much would be left for that? 24, right? So Y is going to be 24. So 16 ounces of mini Starburst. The mini Starburst is important, guys, because they're the ones that don't have wrappers on them. You know what I'm talking about? Like regular Starbursts have wrappers. Don't mix those in there. You got to peel all the wrappers off. And quick shout out to Lily Garrison for making the candy for us. And then what? 24 ounces of sour Skittles. How do you feel about a mixture problem? Mixture problem. The weird thing is take your mixture number times your total number in that spot. Cool?